Here we'll be looking at some of the effects of remanent magnetism inherent in the pole face rotor of an AC alternator. And right now we have a certain resonance set up, determined Li and Ci delta series resonance. We have voltage meters on the outside of the triangle, and we have amperage meters on the inside of the triangle, and we're taking readings essentially of a capacitive reactance. The capacitive reactance has been measured. We'll do that probably in the next video and look at some other stuff. But right now what we're concerned with is actions of remanent magnetism of the field rotor. And over here then, even before we start anything, we can turn the field on, and then we'll turn the field back off again. And on the right then we got well, we should back up a little bit. You see then, for the field of our alternator, pardon me with my camera difficulties. I have to back out sometimes to see what I'm doing. There we are. We have a solid state 7.5 volt supply, and that's an expensive one. The more, not the push-pull supply, gives us a pure DC output. We also have 6,000 microfarad in parallel to that supply electrolytic capacitor, and we also have 2 large 4 ohm resistors in series with that field output. And so essentially we're ballasting the field output by that 8 ohms in series. And then at the end of that chain, of course, we have voltage and amperage meters. This is what energizes the rotating electromagnet referred to as a field in the alternator. So we'll turn that on real quick and see what we're getting. And according to theory, we should always get that amount for that setting. There's no kickback effect from the operating alternator on that field quantity, but we might see some contradictory evidence concerning that. And do a focus on there. We seem to have, at that junction, 0.39 volts enabling history. There's a clip in the way? Yeah, there sure is. 0.37 volts enabling 0.44 amps on a cheap hardware freight $6 DC amperage meter. You can't always trust them. Okay, now we've pre-energized the field then. These things always get to be problematic. Better not than not. So we pre-energized that field then. We're going to turn that off. Now it's reading 0.47, 48, 3.5 volts. I don't understand why it could vary so much, but it do. Now we turned it off. Now we want to look at what happens on the alternator itself with this so-called 13.6 microfarad load. And then, of course, we have in consecutive order, in from left to right, phases 1, 2, and 3, and the amperage meters, which as shown are in the center of each of them DSR quantities. And now we need to get in there and turn this thing on and show what things look like before the field's energized, what things look like after the field's energized, and then what things look like when we reverse the field connections. which of course I've been ranting and raving for years about the fact that there has to be a predetermined direction for that rotating electromagnet to follow. If we don't follow them rules, we're going to get a reduced output. We'll be looking at what that reduced output actually is on a capacitive load. As you should be able to see, those amperages are balanced. Somewhat at least. Now we're going to focus up to the field readings. And we're going to turn the field on. We can compare what the field was with a non-moving field to a moving field. Now we notice the supply is around 4.8 volts, 4.9, and enabling 0.30 of an amp. Now we look at our conditions on the device. It'll be a three-phase alternator. And we see 0.19 pretty average on 4.3 volts. Now we'll turn the field back off again. And then we can see we probably got the same results as we started out with because the field was magnetized in that direction. Now, of course, the next crucial step then is to reverse the field direction. Which I should probably show. And you go in there behind the alternator. If I can. You can see I'm going to reverse the field direction. Yeah, that happens. Okay, I guess we're ready to reverse that field there. Burn my knuckle a little bit, when I've been drinking and this and that, we don't realize how critical these things are. Now we turn it on. Now, I don't know if that's the same result as we got before. Well, let me tell you what. There's your new output. Nowhere in the literature does anything or anybody say anything about the correct introduction of the current to the rotating electromagnetic field of a three-phase alternator. And then there's your proof of the difference between the outputs we obtain, but we obtain them on a capacitive load of 13.6 microfarad. And therefore, to be fair about it, maybe we should call the same thing with an inductive load matched to that resonance. Okay?